today's lesson, we are going to start something which is an extension to the ellipse. So today we are going to look at eccentricity of an ellipse. This is a very important part of ellipse because it really shapes most questions to do with ellipse. So the mathematical definition of what eccentricity is, it is just E, which is the first letter in the word, equal to C over A. Now you remember what C is. C is the fork. Now what is C? We know that C squared is equals to A squared minus B squared for the ellipse. Why? Because A is always greater than what? B. And C will be the root of A squared minus B squared, like this. So this can end up being written as the root of A squared minus B squared over A. This is the mathematical definition. So now we can be asked questions. As the following question which I'm going to give you. So the first question we are going to look at is, they can say that you need to find the eccentricity, which is, I'll just represent it with E, of 8x squared plus 9y squared equal to what? 18. Now for the ellipses, you know that our formula needs to look like this. Ax squared, it's supposed to be x squared divided by a squared plus y squared divided by b squared equal to 1, or vice versa, a squared over b squared plus y squared over a squared equal to 1. So now your a squared will be the bigger of the two. So now how can we get 1 here? We did this in the previous video. We're going to divide by 18 throughout, by 18 by 18. So knowing, we can see that for this part we're going to get 4x squared over 9. For this part we're going to just get y squared divided by what? 2 equal to, this is just supposed to be 2 equal to 1. So now how do we obtain this pure form where we're just having x squared on top and y squared on top? Because look at this, it is the same as you having what? You're still having x, you're having 4x squared. So how do you take the 4 to the bottom? So I'll show you. Let's say this is the same as 4x squared. It's the same as 4x squared multiplied by 1 over 9. This is just the same thing. So I can come and say that if at all, how can I rewrite 4? How can I rewrite 4 so that it still becomes the same? You ask yourself this question. 1 over 4. This is just the same as 1 divided by 1 over 4, which will be 1 multiplied by 4. So this expression is the same as this expression, which takes 4 on top. So that's what we are going to do for 4. This is what we are going to do for 4. So we're going to rewrite it as 1 over 4. So we know there is an x squared multiplied by 9. So this will end up being what? X squared over the 9 goes there, 9 over 4. So now we have made it in the pure form. We had it plus y squared divided by 2 equal to 1. So now we have to ask ourselves, which one is bigger between the two? Is it 9 divided by 4, which is 9 over 4, or 2? Which one is our A? 9 divided by 4, it is 2 point something. So this is our A. So A is, it's our A squared, in fact. A squared is equals to 9 over 4. Then B squared is equals to what? 2. Now, we know that they are telling us to find the eccentricity, which is E equal to C over A, isn't it? So now, how do we find C? We know that for C is equal to what? A squared minus B squared with the root. So it's just 9 over 4 minus 2 with the root. So now, what is 9 over 4 minus 2? What is 9 over 4? It is 9 over 4 minus 2. So this will be just 4, 9 minus, then this will be 8. So it will be 1 over 4. It will be 1 over 4 with a root. So this says C is equal to what? 1 over, this will be 1 over 2. This is our C. Our C is equal to what? 1 over 2. So now, since we have found C to be 1 over 2, and we need A, we know that A squared is 9 over 4. So 9 over 4 is equal to what? A squared. So root. So A is equal to 3 over what? 3 over 4. So now we just need to follow the formula. So in our C is 1 over 2. Then this is divided by our A. Our A, which is 3 over 2. Sorry for this. This is supposed to be 3 over 2. The root of 4 is supposed to be 3 over 2 divided by 3 over 2. So this will end up being what? 1 over 2 multiplied by 2 over 3, which will be 1 over 3. So this is our final answer for our question, which was requiring us to find the eccentricity of the ellipse, which is 1 over 3. So now, what is the importance of us knowing this? What is the importance of us knowing how to find this guy? So the importance will be outlined in the following example. I'll give you this example. Let's just clear up. All right, let me give you this question. They can ask you a question of this man. They'll tell you to find the answer. The question is for you to find the equation of the what? Of the ellipse. Told to find the equation of the ellipse. Then they're telling you that the fork is 0, plus or minus 8. Then they have said that the eccentricity is equal to what? 4 over 5. And then they have also even told you to do what? A sketch of the graph. So now you can ask yourself, for me, I like understanding these things. Now ask myself, what is the fork? The fork is C. So the coordinates for C are 0, 0, 8, and 0, -8. This is what it means here. Then we are given the eccentricity. Now what is E? E is equals to C over A. So we are given this and this. We can find this. This is how powerful this guy is. So what was our E? Our E was 4 over 5 equal to, what was our C? Our C was equal to 8 divided by A. So we can see that 1 over A is equal to 4 over 5 times 8, which will be 4 over 40. Now what is 4 over 40? 4 over 40 is 1 over 10. So we can multiply. Now our answer is equal to 1 over 10. 10 multiplied by 1 and a multiplied by 1. We are having a equal to what? To 10. So now since we have found our a, we have found a, we have what? We have c, which is 8. So we can say that a is equals to 10, c is equals to what? 8. And what do we know? We know that c squared is equal to a squared minus b squared. Now how do we find b? B squared is equal to a squared minus c squared like this. So now b will be the root of a squared minus c squared. Now what is a squared? A squared will be 10 squared, c squared will be 8 squared. So we're having 10 squared minus 8 squared, the root. So this is just the same as 100 minus 64. So this will end up simplifying to what? The root of 36. This will be the root of 36. This is just the root of 36. This is the root of 36. So meaning b will equal to what? B will equal to 6. This is our b. So now we know that b is 6, a is 10, c is 8. Meaning b squared is equal to what? 36. A squared is equals to 100. And c squared is equals to 64. Now we know that what we need for the ellipse is this and this. So we have to ask ourselves, our question will guide us. What were the coordinates for the fork? The coordinates for the fork was 0, positive, negative, 8. So we know that the fork is always along the major axis. So now this is x, y. So it means our ellipse was like this, since we know that the fork will be here and here. So now what are the coordinates? What are the coordinates? What is a? What is a? A is 10. So we're going to have 10 there, and we are going to have what? Negative 10 here. Then these parts, we're going to have what? What is b? 6. We're going to have 6 here. We're going to have 6 here. Then the fork we know we are given, which was 8, and here it will be negative 8. So just be neat on your drawings. Just be neat on your drawings in your book. So then the equation we just need a squared, and we know a squared was along the y. So our equation will look something like this. X squared, for x is the minor axis, so it is for b 36 plus y squared divided by a squared is what? A squared is 100 equal to 1. So this is our equation. So this is how this powerful tool, or this small topic, is really important under ellipse. So from here we'll be moving to applications of ellipse, to the applications of ellipse. So under the applications of ellipse, you find things like, the most important things you find under the application of ellipse is, this is an ellipse. Let me just draw this. Let me try to draw it nice and well. Yes, this better. Then there's a sun. This is a sun. We know the earth and all the planets, they follow, it's not a circle, it's elliptical path. So this is just a random planet like earth, where we are, or Mars. So this is the sun. So the distance from the ellipse, the distance from the ellipse edge, which is near the sun, to the sun, to the center of the sun, to be precise. This distance here, it is called perihelion. And now the distance from the sun to the planet, this the longest distance, is known as epihelion. Now there's this distance from the vertices to the center. So the distance from the vertex to the center, this distance here. So this distance from this line to the vertex, from the center to the vertex, is known as mean distance. So for the application of the ellipse, you just need to understand this. You need to know what perihelion is, epihelion is, and mean distance is, because that's where all the questions just revolve around. So if you know and understand what epihelion is, what perihelion is, and mean distance is, it will be very easy for you to navigate through the questions. That is mostly for these guys. So the formulas are very simple. They would ask you to say, maybe they give you the mean distance and the epihelion. So they can give you epihelion and the mean distance and tell you to find what? Perihelion. So how do you go about it? So perihelion is equal to 2 multiplied by mean distance. So I like writing it this way. Mean distance, then minus epihelion. So you can see that this is just the same thing. So now it's the same if they're telling you to find epihelion. So if you are finding epihelion, you can see that this entire equation would turn into epihelion is equal to 2 multiplied by mean distance minus perihelion. So it's just that they just change. When you're finding peri, you're subtracting epi. When you're finding epi, you are subtracting what? Peri. So this is just where all the questions are going to revolve around. You know, there's this question which is telling you to say they've given you the mean distance. Then the question reads, I'll just read it. The question says the earth has a mean distance of 93 million miles. I've said miles. Then they said that the perihelion is 9.5 million miles. And then they tell you to find the equation for the earth orbit. So it's more like they're just telling you to find the equation of the ellipse. So if you understand, now it all gets back to your understanding what peri is. You know that peri is the shortest distance, which is similar to what? Which is similar to what? If you can just ask yourself to say, what is a peri? So before answering this question, I would want us to look at it again. We know, if I say this so that we bring it home, we know that the distance from here to there, considering that this is the major axis, this will be what? A, isn't it? Then the distance from here, this part, to this part, this is where the fork is. Then From the center to there, we're having B in between. So we can see that this distance, it is the same as what? It's just the same as we can see that this distance is perihelion. This distance is perihelion, and yeah, just a quick correction. Yeah. So this distance here, it is perihelion, but we know that this distance from the center to this the fork, the distance we have here is what? Is C. So the distance from the center to the fork is C. So now, how do we find this distance, the C part, if we are given the perihelion and the what? The epihelion. So we can see that, let's say you have a straight line and someone gives you the distance from here to here, and he also gives you a distance from here to this part. Then he tells you to find the distance for x. You're told that this line is A, this line is what? Is B. How do you find x? You just say the longer side, which is A minus B. So if you have the epihelion and the perihelion, you can find what? C. So C is equivalent to epihelion minus perihelion. That's C. Then the mean distance is A. So once you find A and you have C, you can use what we have from learning. You can just use what we have from learning, eccentricity, and you find what? B. So once you have B, you have A, then you can write the equation. That's how super cool it is. Or even if they haven't given you the eccentricity, you can just go ahead and say that C squared is equals to what? A squared minus B squared, and make B squared the subject and end up finding B. So that's how we are going to solve this question which we have here. This is how we're going to solve this question we have here. We were given the mean distance and perihelion. Given the mean distance and perihelion. So let's just clear up. Okay. So now, dear friends, if we are given the mean distance and perihelion, we need to find epihelion, so that we'll find what? C, because we know that mid distance is the same as A. So epihelion is equals to what? 2 multiplied by mean distance, which is 93, then minus 91.5. So let's get our calculator. Say 2 times 93 minus 91.5, which will give us 94.5 million miles. So now we have this, our epihelion. So now we know that C is equivalent to epihelion minus perihelion. So which is just 94.5 minus 93 minus 93.